Welcome. I am Garima Tripathi, Assistant Professor RKGIT in Pharmacognosy. We shall be discussing the topic chromatographic techniques in phytochemistry with HPTLC, TLC column chromatography. Under this technique, the first choice of discussion is the thin layer chromatography or TLC. So, as already mentioned in the earlier lectures, that chromatographic separations on the can be divided as planar as well as non-planar or open column technique. Open column technique. So, the planar chromatography suggests that there has to be a solid support with glass plate or any other solid support on which the adsorbent layer is added along with the stationary phase, and this complete planar system is dipped into mobile phase, and the development or what you say the separation of the solutes takes place. Herein, let us discuss that this is one of the most widely used technique. It is fast in nature and can be utilized for qualitative analysis of mixtures. Let us have a light on this. There are in any analytical method, there could be two utilizations. One is qualitative and the other one is quantitative. So, all these techniques are utilized either for qualitative or for quantitative. That means quality means identification of something or the identification of something, and in quantitative we generally go for the methods wherein estimation or the amount with which these solutes are present to calculate that amount. So, thin layer chromatography is a very basic technique and it is mainly used presently for the qualitative analysis purpose. So, herein there are having stationary phase which consists of a thin layer of adsorbent like silica, alumina, cellulose on a flat carrier glass plate and thick aluminum foil or a plastic sheet. So, TLC has certain advantages of the last discussed paper chromatography, that is fractionation can be effected more rapidly with smaller quantities, and the reason behind this is the silica which gives is additionally the adsorbent surface apart from the partitioning of the solvent system used or the stationary system utilized. So, the separated spots are usually more compact and more clearly demarcated from one another. So, let us have a look. In any planar chromatography, we leave a 2 centimeter, almost a 2 centimeter area, mark it here, and then we apply the sample with the help of a spot. With the of a spot, and this once the mobile phase starts running, the solute present in this area is carried and gets separated out in the form of the spots. So, this demarcation or the separation is far better when we use a solid plate with silica adsorbent and solute as compared to paper which is having cellulose base. Next, the TLC plates are made by mixing adsorbent with a small amount of inert binder called gypsum or chemically which is calcium sulfate. As the solid support, the adsorbent needs something to get adhered and binded over the solid support, and that is achieved by the addition of gypsum and water. Any other binders also can be utilized for this purpose, but this is one of the most commonly utilized binder, and hence you will see the grade of silica which is being used says silica gel G, that means the one which is having added G or the gypsum, and if it is not having any binder into it, the silica used would be termed as silica H, that is only homogenized H. Okay, next, spreading this thick slurry on the carrier, drying the plate. Activation of adsorbent is done by heating in the oven. So, the activation stage is also very important in TLC. Why? Because the adsorbents which are on addition of water, water is being utilized to make the slurry of the adsorbent silica gel, and if at all this gypsum is added, it also needs water to initiate the binding state. This extra amount of water has to be removed from the plate so that the surfaces are free to interact with the solute and the mobile phase. So, activation is done at the temperature of around 110 degrees centigrade for 30 minutes to 1 hour depending upon the conditions. In BP it mentions 120 degrees centigrade. Overheating of the silica plates are not advisable as it loses its ability of capillary of the adsorbing ability. So, overheating is not advisable. The adsorbent which is utilized should be typically around 0.01 to 0.0225 mm for any analytical purpose, and around 1 to 2 mm for preparatory TLC. As already mentioned, preparative TLC is utilized for extracting or isolating the analides in a higher or larger amount. Sometimes this isolation could be at the gram level as well. And again, this preparatory TLC is utilized for production of or manufacturing of the active pharmaceutical ingredients for analytical purposes, and they need to be obtained in a purified form. At that stage also preparatory TLC is utilized. Okay. So, there are various methods which make the colorless spots of the TLC visible. Often a small amount of fluorescent dye is added to the absorbent. That means when at the time of preparation of the slurry of silica, along with it a binder gypsum is added, and along with that another fluorescent dye is added, which in turn gets adsorbed to the silica, giving it the ability to fluoresce at a particular wavelength, and this allows the visualization at UV absorbing spots under the light at wavelength 254 nm. Okay. So, UV light without fluorescent dyes could also be utilized to scan the compounds, both in long, that is 365 nm, or short, that is 254 nm wavelength. Another very generalized and unspecific reagent that is utilized is iodine vapor for the determination or of the solutes or the separation. Okay, specific color reagents can also be utilized in TLC by either dipping the plate into the reagent system or spraying onto the plates. So, one such example is Dragenhoff's reagent being used for detection of alkaloids, and this is done by the spraying method. And then another example is antimony chloride in chloroform, which is used as a spray reagent for determination of steroids. So, the outcome what we learn from here is that once we want to go for visualization of the separation, we are having two major types or major methods. Number one, either utilizing by light or by chemical treatment. So, this light has the variations as you already saw, either utilizing visible light or UV light of short wavelength and long wavelength. Short wavelength is 254 nanometers while long wavelength is 366 nanometer, and the second method is the chemical treatment, where we are either utilizing the reagents by spraying onto the separated spot, or they are being dipped. The examples here are given at the as already discussed. So, there are some more examples under our consideration, like the anthraquinone compounds. They are easily visualized by ammonia vapor, and then we have this fast blue salt B, which is used for visualization of cannabinoids and fluoroglycinol like substances, okay, and it is again effective, comparative, cheap, relatively very small amount of the analytes could be easily separated, analyzed or assessed with utilizing TLC. This TLC could be utilized into day-to-day in a routine manner. We can utilize thin layer chromatography for the analysis and research purpose. That makes it handy and more advisable. Okay. Next is adsorbents and solvent requirements are also less than many of the sophisticated instruments that we are using for analysis. Next, the use of appropriate developing agent can help to understand the compounds and its property, and can be quantified by careful standardization of protocols, and hence this method of TLC plays an immense importance in the day-to-day pharmaceutical research, as the nature of the compound, that before structural elucidation, before we are knowing whether the what substances are or the solutes that we have separated out, we can actually assess the nature of the solute, or even if it is a known substance, simple steps will help us to perform the day-to-day routine analysis of these drugs. This is the diagram for the description of the thin layer chromatography as already described. See here, simultaneously 3 spots are applied. This mark suggests that the solvent layer, when we are dipping, should not be above this mark, or else if it touches this drop, there will be the movement sample will contaminate the mobile phase present in the development tank. Okay. So, the direction in which the mobile phase or the solvent moves is in this direction. This is the control, that means standard. Supposingly we are utilizing, we have to assess unknown sample from the market containing alkaloid named morphine or so. So, the sample is generally kept, the test samples are kept here, and one control, that means standard morphine opium drug, if morphine opium drug is available, that drug is kept for control, for comparison, and the component which morphine is plotted here, or so that the reference the separated compound can be easily identified. So, this is how, this is the control and this is the reference of that particular point. So, that suggests that the test sample which I are having is having the component B, that is morphine from the opioid sample, and this is component A, which is some control, some marker, some biological control is also available in the original sample. So, the amount with the distance to which these solvent front has moved, that is marked after taking out, and then this Y is the complete distance travelled by the solvent system, while the separating mark, this is the X, is the distance travelled by the solute. So, RF value, that is the retention factor, is calculated as X divided by Y. So, This does not have any unit and it is always less than 1. So, and again polarity, since we are using, this is a normal phase chromatography, where stationary phase, that means the silica adsorbent along with the moisture acts as the stationary phase, is a polar one, and the solvent system which is being kept in the tank is non-polar. So, the substance that is extracted is in this series of polarity. Okay. So, the next topic of discussion is the high performance thin layer chromatography, which is also termed as HPTLC. This HPTLC is again very similar to TLC, only it is automated and is more sophisticated than the TLC and utilizes all the advantageous parameters of TLC in terms of qualitative, quantitative analysis of the natural product. The principles of separation of adsorbent is same as that of TLC. In HPTLC, the pre-coated plates are used and the particle size of the stationary phase is less than 1 micrometer in diameter. There is a wide choice of stationary phase like silica gel for normal phase chromatography and C18, C8 columns for the reverse phase chromatography. Now, HPTLC provides higher efficiency than TLC because the adsorbents used are of small and uniform size. A very less amount of sample is spotted on the plate. So, the sample prepared should be highly concentrated and it avoids even the overloading of the sample, which is quite a possibility in TLC. The size of the sample spot should not be more than 1 mm in diameter. The samples are spotted by various techniques and commonly used methods like semi-automatic Linomet 5 apparatus. New types of developmental chambers are being utilized in HPTLC that require lesser amount of solvent for the development of the chromatogram. So, let us have a look. Generally, in chromatography, when a 20 by 20 plate is utilized for TLC, we have to prepare a solvent system almost from 250 ml, while as compared to that in HPTLC only a 15 ml tank is available, and since the adsorbent is already available in a pre-coated plate on an aluminium sheet, it takes some time, is also reduced in the development. So, there is a marked difference in the solvent utilized for the separation of the solutes, and hence it is a more preferred one. A linear development technique is commonly utilized. The plate is placed vertically in the development chambers containing the solvent, and the chromatogram can be developed from the sides, giving you insight in the various types of developmental chambers available for HPTLC. Here some double troughed or S-shaped chambers are available, which are very thin and does not allow much of the space, making more uniform development of the chromatogram. HPTLC, in HPTLC, UV visible and fluorescence scanner is used. So, this is an additional instrument that is being utilized. Therefore, it scans the entire chromatogram qualitatively and quantitatively. The scanner is advanced type of densitometer. That means, whenever the plate is already developed, either we can visualize qualitatively, determine what are the solute material present, what are the various components present in the given complex mixture, with if it is having component A, component B, component C, all these could be determined qualitatively, or else if a control and the amount of the control is already given its density, calculating the density, the scanner can compute the amount, estimate the amount of substance with the solute A, B and C. That means it can determine quantitatively the solutes present or the analytes present in the given sample. HPTLC is used for standardization of the herbal extracts and other formulations. That's why this technique is now being incorporated in IP and other official pharmacopoeias for the fingerprinting assessment and standardization of the herbal medicines. Using this technique and the analytical profile of alkaloids, cardenolides, flavonoids, lipids, steroidal compounds, etc. have been developed. So, here is a comparison between the TLC and HPTLC, as plates in HPTLC are only pre-coated. They have this adsorbent at this 100 to 200 micrometer thickness, while it is 250 micrometer in thickness. Pre-washing plate is not done in case of TLC, but it is a must in case of HPTLC. Application of sample is done manually or semi-automatic devices can be used. Here only the application could be done under a semi-automatic or automatic device. In TLC, we apply the samples in spot form only, while we prefer to apply bands of the sample by the automated device in a calculated and manner as bands. Sometimes spots could also be applied. Spot size is small in case of HPTLC, like 0.5 to 1 mm, while it is larger and has the problem of overloading. Here the application of larger volume is also possible if we direct the instrument to have a larger band, length and width. So, these are the display of the instruments. As said, in TLC we are having simple glass developmental tanks, while in HPTLC we have these specialized automatic developmental chamber where the solvent system is kept here and the alumina plate pre-coated with adsorbent are kept vertically on this development chamber. Okay, then this is the Linomat 5 applicator. Here you can see there is a place to put an injection which is combined with this wire, and it is attached to the nitrogen cylinder. This nitrogen cylinder purges the amount of the required spot or the band. All the digital controls are available to release the estimated or decided quantity or volume of the sample. Okay, this is the scanner. After the development, the plate is taken, the shutter is opened, and inside that the plate is kept. So, this scanner contains two types of lamps, UV and tungsten. This gives it the ability to scan and on the absorption parameter or at the transmittance parameter. The lamp once scans the HPTLC plates, and when it compares with the control, the density could be assessed here in a software which is already automated. They follow a WinCat software, and finally whatever result or band that we have obtained is visualized in this digital camera, which is able to preserve in the soft data. So, this is how the HPTLC plates look like. The bands, the separated components of the herbal extract. Here we have shown how the identification of anthocyanins, identification of alkaloid under UV 254. Since UV 254 is used and the pre-coated is a silica GF254, where F254 is the fluorescent dye that was added into the plate, and this is the PAs which were identified in the chocolate sample. So, this is one is visible, one in the 254. Again, this is the after derivatization, that means after the chemical treatment it was observed under the UV. Okay. So, another very important application of HPTLC is to determine the contamination of dried medicinal plants, crops, nuts, fruits, vegetables by the estimation of aflatoxins like G1, G2, B1, B2. Here two graphs are shown where G1, G2, all these peaks are of the given control or the reference of the G1, G2 toxins, and this is the calibration graph of the aflatoxins measured at 366. Utilizing this, the contaminations in the plates or in the given sample could be assessed. Here is another example or application in food industries. From age-old times, HPTLC is being utilized for identification of various adulterants. Here Sudan dyes in dimethyl yellow etc. in red chili powder are identified. Identification of addition of melamine to low protein content in adulterated milk is shown as well. So, these are some of the applications. You can see here that the track 6 shows the presence of Sudan 1, Sudan 2, then we have this Sudan 3, 4, and all these are adulterants, and once the test samples were applied, all the adulterants was easily identified, and this is what is called as the fingerprinting technique with which we can identify. Next is the column chromatography. Column chromatography utilizes vertical glass columns filled with some form of solid support with the sample to be separated on plate. The rest of the column is filled with a solvent which under the influence of gravity moves the sample through the column. Similarly, to other forms of chromatography, there is differences in the rates of movement through the solid media and are translated into different exit times, nothing but the retention time from the bottom of the column for various elements of the original sample. That means the time of exit of any fraction will be the will say the difference in the type of solute. So, this is here is the description. This is the packed column, glass wool is filled here, plug is kept there. There is the mixture, this is the sample applied here in the over the stationary phase, which is having silica gel, sometimes N-hexane is also a slurry is mixed or a solvent stationary phase is kept. Then the solvent is put here. This solvent with time will imbibe the sample and will reach to the stationary phase. Once it starts reaching in the stationary phase, according to the affinity or separational power, various bands, it will start separating once it nears to the exit, and finally component A, B, C would be separated out. And since this has lesser affinity and A is being washed out initially, the first elevate at a given temperature at a given time would be elevated at the beginning. And before coming to the reference, here the concept of theoretical plate exists, which gives the better resolution. That means the sharp difference or sharp separation between two fractions, two bands. So, that is calculated with the help of theoretical plate, and it is given resolution R is equal to root of n by 4 by gamma minus 1, where gamma is the separational factor, n is the number of theoretical plates. Number of theoretical plate, that means that the whole column is imagined to be divided into various plates, and imagining that these plates will contribute to the separation, and the factors that will affect is given as the constant, and that's how the resolution or the separation could be determined. The whole lecture was referred from S.L. Dore and Biren and Shah, textbook of Pharmacognosy and Phytochemistry, and I thank you